Hey guys, today during this session, I will explain five architectures about warehouse and meta server. And in the upcoming session, we are going to cover all these things: Hive architecture, Hive meta store, Hive data types, internal and external tables, Hive optimizations. Inside optimization, we will cover all these things: partitioning, joins, Hive file formats, CPU, vectorization, indexing, how to integrate Hive with Blaze and Spark engines, Hive serializer, deserializer, Hive integration with NoSQL, Thread API, UDF, multi-delimiters. So these are the things which we are going to cover in the upcoming session. But today I will explain this Hive architecture. So this is uh, this is our Hive architecture. So as we can see in this diagram that we have Hive clients, Hive services, and inside Hive services, Metastore and Hive file system. So this is Hive warehouse where actually Hive puts its data. And these are the Hive external clients for Hive. We can interact with Hive with the help of JDBC, ODBC, and using a thrift client. Now, um, I'm explaining this part with this diagram. So, in the below section, we have HDFS. We have HDFS. This layer is data storage layer. Data storage layer. Now, on top of HDFS is yarn. On top of yarn is Hive server. Just to understand how Hive works in the world. This is the Hive server. After Hive server is Hive client. Now in Hive clients, we can say HQL, a SQL interface. It can be a Python client. It can be a Java client, or it can be a C++ or any other language, any other language. Now, when we submit any query, this request goes to Hive server. From Hive server, the request goes to yarn, and from yarn, it goes to HDFS. Now, inside Hive server, my HQL query is converted into MapReduce. My HQL operation is converted into MR, and then MR submitted on yarn, and it will operate on HDFS. So this is how HQL works internally. So if we are here as a Hive developer, we are operating on this layer, and we will submit our request on Hive server, and internally Hive server will do this sort of thing. And then actual MR job is submitted on HDFS. I'm showing you the practical example. As we can see, so this is my environment, Cloudera distribution. Now, this is the web interface. This is web interface. So here we can see Hive shell. This is the web interface. Here we are saying web interface. This is my web interface. By the diagram, we are saying CLI. CLI is this part. Hive shell. So just write Hive shell. So you will launch a Hive shell. Okay. Now I am going to create our data. I'm going to create a table inside Hive, and then I will show you the warehouse and the metadata of Hive. Now this is my data set. This is my data set. So this is our comma separated file. Now Hive is similar to SQL. So to load any data in Hive tables, we need to create schema first. So we can create a table schema post 300 user string, post is of type string, time is of type second. Row format delimited, fields terminated, and data is, the fields are comma separated. As you can see, these are comma separated, so that's why we are writing comma separated, stored as text file. This is my file format. So we will cover this part in upcoming sessions. So there are multiple file formats available in Hive. Text file is one of them. Text file is the default file format of Hive. Now, table is created. We can change the schema. Post 300. So as you can see, we have this table structure. Now load this data. This is my data. Now load this data into this Hive table using a load command. Load data local in path. My data is on desktop. I'm giving the path. Desktop. Data. Overwrite into table post 300. Now data is loaded in Hive table. Now, as I told you that Hive loads its data in warehouse and it stores its metadata in MySQL. So this is MySQL. Here show tables. These all are Hive metatables. These all are Hive metatables. Now here DDLs. Inside this table we have a meta information of each and every Hive table. So this is the metadata. This below the bar is showing my latest table name. This post 23, post 300. Now, what is metadata? Metadata is this part. Meta information showing the creation time of this table, the owner of this table, retention policy of this table, what's the table type. So we have two types of table, internal table and external table. Internal table is also called managed table, and there is one more table, external table. So this provides the meta information. Now Hive store its actual data in Hive warehouse. In Hive warehouse type. HDFS is the warehouse. HDFS is Hive default warehouses. Hive default warehouse is HDFS. HDFS is the default warehouse. And Hive store its meta information. Hive store its meta information in any RDBs. Hive meta server. So Hive meta server can be any RDBs. So in my environment, it is MySQL, it can be Oracle, it can be Postgre, it can be MySQL. So we can configure any RDBMS server as a meta server. Now we can verify that this is the meta inside MySQL and actual data is persist inside HDFS. So HDFS is just a minute. This is my HDFS. Now user Cloudera user Hive warehouse. This is the actual Hive directory for Hive. Warehouse directory for Hive. We can see post 300. This is the table which we created in Hive shell. We created this table, then we load our data. So it stored its actual data here inside its tables. So here we can see that my data is here. My meta information is here. Now we can query on that data. Select star from table. Now this data is in our tabular format, and its actual data is behind the scene. It's inside HTML. So this is showing the Hive internal operations, Hive internal architecture. This part, this meta store, meta database. So this part is this is the actual meta information. And as we can see in this diagram, this Hadoop cluster, this is my warehouse directory. So this is my warehouse directory. So we can say Hive is a data warehousing package, or you can say it's a SQL engine on top of Hadoop, or it's a SQL-like interface on HDFS, from where we can query on HDFS dataset. So that query language is my SQL, and mainly we used Hive for data warehousing applications or reporting purpose, where we extract financial and quarterly reports. We use Hive for that purpose. Mainly, we use this as a OLAP. So internally, as I told you in this diagram, that when we are submitting any query on Hive server, so here we can see that we are running these queries on Hive shell to reach to extract data from the table, or to load any data in a table, or any sort of query. All are converted into MR internally. My HQL operation is converted into MR internally. And as it is converted into MR, then a job is submitted on Yarn. On Yarn server, Yarn manages multiple resources at the same time, and then it passes on to this HDFS layer, Here this HQ query executes and provides the results. Uh, so uh, this is the actual internal architecture of Hive.